Hello everybody and welcome back to a new video. Today we're going to look at Law of Cosines, and this is for Foundations of Mathematics 20, Acute Triangle Trigonometry. All right, so let's start off with a problem. Here is a triangle, and I'd like you to solve for x, okay? So to solve for x, we have to set it up. So if you guys could just take 30 seconds and think about how you'd solve it, set it up. I'll give you 10 seconds of dead air. I'm going to count elephants in my head while you check things out. 5 elephant, 8 elephant, 10 elephants, because a lot of you aren't playing, so I don't want to spend too much time on this, but thank you for those who did. If I try to set this up, I'm just going to look at the way we tried to set it up yesterday, or whenever you would have watched this video. And that's with this little list method. Now remember, it's nice. It gives you a little bit of organization, but it also helps you determine when you can use sine law. If you have a row, you're good to go with sine law. So I have angle C is 15. Then I have side B is 14. And then side A is 12. Okay. Well, we didn't always have a row at this beginning of a question with sine law, but then if we didn't have a row, we'd be able to kind of complete the row quite easily. So let's think here. Can I do my 180 trick on this side? Yeah, and the answer is no, because those are side lengths. You can only use it on the other side. So there's an issue with this one, and the issue is that I don't have that row, and there's no way I'm going to get that row. So if you don't have a row, then what you have to, well, then you can't use sine law, and you need something else. Okay, so sine law is great, but it doesn't work in every situation. That is why there's such thing as law of cosine. So like I just said, the law of sines is great, but it does not work for all acute triangles. Due to this, another tool is needed. That tool is the law of cosines, also referred to just cosine law, so whatever you want to say. And if you're given a triangle, A, B, and C, with sides A, B, and C, remember the corners, the vertices, they're capital letters, and the side lengths are the lowercase, and that if your angle is A, then the side opposite it, the side across, right? The side across is little a. So that's how that works. Anyway, here is the formula. A squared equals B squared plus C squared equals, minus 2BC times cos of angle A. All right, now we won't get into deriving the formula because I don't want to make this video too long, but yeah, you can see there's some Pythagoras in there, right? You can see the A squared plus B squared, or A squared equals B squared plus C squared. So there is some Pythagoras in a proof we could do, but we're not going to worry about doing that. And then there's 3 different ways you can write it. Okay, so this is if you were looking for side A. This is if you're looking for side B. Now there is a pattern here. If you notice that it's the one that you're looking for, and then it's just the other 2 squared, and they're always added. Then it's always a subtract 2, and then it's these same sides again. Okay, so it's AC and then cos of whatever you were looking for. So if it was B squared at the start, it's cos B. So if you check out the C version, so you can see here it's C squared and then it's cos C. And then it's just the other 2 sides, so A and B, and then again, they're included over here. Okay, so there is a pattern. You will get it down. It might seem confusing at the start though. So if it feels confusing, don't worry, you guys, it'll get better. So with that, let's get right into things. Okay, again, I like using my little list. You do not have to. This would be what I call a Troyism. Okay, it's something I like doing. It is not essential, but it helps with organization and it can help with decision making. So they are giving me angle C, which is 15 degrees. And this is the same question again, right, guys? I don't know if you've noticed that. So that's 14 and A is 12. So because I have no row, I have to use cosine law. Now, another way of looking at it, there's no angle side pair. So there's the angle, 15. So I would need to know side C as well in order to use sine law, and I don't. Okay, so that's why we're going to use cosine law. Anyway, I'm looking for side C, so I'm going to use the C version. So it's C squared equals the other 2 sides, A squared plus B squared. And then it's going to be minus 2 every single time, and then those same 2 lines, or sorry, 2 sides, AB times cos of whatever you were dealing with, which was C. Okay, I'm going to go to orange here. I think it might show up a bit better. Okay, so anyway, c squared equals a squared is, so it's 12 squared plus 14 squared minus 2 times the a value, which is 12, then 14, because that's the b value, cos the c angle, which is 15 degrees. Just another heads up, make sure your calculator is in degrees, everybody. Okay, so depends on the type of calculator you have here. There's lots of calculators now. I don't know what you guys are rocking, but there's lots of calculators that you could type this whole thing in one set of keystrokes. And that's what I do. So I typed the whole thing in, and I got 15.4. But you can go through it in phases. You could go, 12 squared is 144, plus 14 squared, 289. And then minus 2 times 12 times 14 times the cos 15, you'd write that down. So you can just do it in chunks too, you guys, okay? But the big thing is, notice that c squared. So I have to take the square root. So I don't want just c squared, I want c. So square root of 16 is 4, and this is less than 16, so something less than 4 ends up being 3.9. So I'm going to round to the nearest one decimal. And there you go. So that's the first one. So cosine law. If you thought sine law was easy, cosine law, lots of people find even easier, but that kind of depends on the calculator, like I said. If you can punch the whole thing in, then cosine law seems real easy. Okay. Example 2. Again, you do not need to do this. I am given angle B 36.33. Then I'm given side C 3.25. Then I'm given side A 3.45. Okay, and they're looking for, that would be side B. So once again, I do not have a row. There's no quick calculation to give me a row. So I'm going to be looking at cosine law. So one thing I want to mention right now is that you're going to be solving problems and with acute triangles where you're going to use one of these two laws. The easiest thing, there's only two ways we're going to be doing these things. What I like to tell people is, let's think sine law every time. If you have a row, you're good to go. And then if you don't, now you know use the other. Okay, so I'm going to come in always thinking sine law or always looking for sine law. If I don't have that row, boom, I'm into cosine law. Okay. So I want to use the b version of this. So it's going to be b squared equals the other two sides squared. So that's going to be a squared plus c squared. Always minus 2. Then the same ac. And then cos of the angle opposite of that side. So that if I'm b squared, I'm looking for cos b. Okay. Plug things in. So 3.45 squared. Plus 3.25 squared minus 2. The a value is 3.45. The c value 3.25. And then cos the 36. Am I going to be able to squeeze that in? 3. I think I got that in frame. All right, again, you can chip away and figure out what is 3.45 squared, write down. Plus 3.25, whatever that is squared, write down. Minus, I'd multiply those four things together personally. So I'd go 2 times 3.45 times 3.25 times cos 36.33 and write that down as well. Okay, and then you'd add and subtract and you'd have that number. Or you can just type the whole thing in. And if you type the whole thing in, you end up getting 4.4. Or if you end up doing the other way, I guess, regardless of the way you do it, you get 4.4. And then I'll take the square root, and I know that's close to 4, so this should be, well, it's bigger than 4, so it should be slightly bigger than 2, and it is 2.1. Okay, so that is cosine law with when we're finding side lengths. Now let's look at cosine law when we are looking at an angle. So it's the same law. It's a little bit longer solving process, like the calculation part, but hopefully you don't find it too bad. I'm going to say this every single time. You don't have to make the list. But I am. Okay, so I know side A is 7. I know side B is 6, and I know side C is 5, and then I'm looking for angle C. So once again, I don't have a row, and there's no way to get the row, so I'm going to have to go cosine law. Okay, so if I'm looking for angle C, everybody, angle C is related to side C, so I'm going to use the C version. So C squared equals, again, the other two sides, so A squared plus B squared, then minus 2 of those same other sides, AB, and then cos C. So you could rearrange this to isolate the angle. So you could have angle C equals and then all this stuff rearranged. I'm just going to work with the original formula. I'm not going to rearrange it, but by all means you can. Okay, so you can look that up on maybe another video if you wish, or just anywhere on the internet, but I'm going to leave it. If you memorize the other formula, yes, it's faster, but if you have to rearrange it every single time, you might as well just kind of leave it as is. So it's kind of up to you. Anyway, this is not crazy long. So 5 squared equals 7 squared plus 6 squared minus 2 times 7 times 6. And then I don't know C, so I leave it as cos C. I like putting square brackets around there, so I don't confuse my round bracket with the C because sometimes I'm messy. Anyway, 25. This is 49. Oops. Plus 36. Eraser. Yeah, I didn't say this, but yeah, I can't just type this one in. Okay, so I'm going to actually have to rearrange some stuff. So seeing I'm rearranging, that means I have to actually figure out some of these values. And again, I'm going to multiply these together. So that's, I see 7 and 6 is 42 times 2, so 84 cos C. And now the rearranging isn't hard. It's just not as quick as the previous one. So I want to get I need to get cos C by itself, which means I want to get this by itself. That's kind of my first thing. So I'm going to subtract 49 to the other side, and I'm going to do the same thing with 36. And feel free to simply add those up and then subtract that amount. Anyway, so 25 minus 49 minus 36, I'll get negative 60 equals negative 84 times cos C. And then, yeah, to get cos C by itself, you have to divide. So I always like having, because it's the math thing to do, the math convention, I like having my unknown on the left side. So I'm just flipping it. Instead of having 60 over 84 equals cos C, I'm going to write cos C equals 60 over 84. And notice I'm saying 60 over 84 and I'm dropping the negatives because two negatives make a positive. So you could include those two negatives or you can exclude them like I am. And then now I don't want cos C, I want angle C. So again, this is where you go into your inverse. So whenever you're finding the angle, everybody, we always do our inverse. We're telling that calculator go backwards. So cos negative 1, the inverse cos of this value, 60 over 84. And what's that end up being? Well, it ends up being 44.4 degrees if I round to one decimal place. So you're going to go second function cosine on your calculator. And then most calculators have a bracket, so I'm just going to go 60 divided by 84, close my bracket, hit equals. And then that's what you get. Okay, so that was one example like that with finding the angle. And let's look at one more finding the angle. Because, I mean, it's so gosh darn fun. We have one example after this if you guys are looking at the clock. We're going to do one problem together too. Oh man, I was talking too much. That's B. All right. So angle A is what I'm looking for. I know side A, it's 5. I know side C is 8. Side B is 10. Okay, again, I don't have a full row, and there's no way to get the full row, so I cannot use sine law, so I have to use cosine law. I'm wondering about angle A, so I'm going to use the A version of the formula. So A squared plus the other 2 squared, so B squared plus C squared, minus 2, same other two sides, times cos of A. All right, plug stuff in. 5 squared equals 10 squared plus 8 squared minus 2 times 10 times 8. Cos of angle A, we don't know. I was looking for the A value here. I forgot what I was doing. All right, and again, there's no quick way. I actually have to calculate and determine these values. So 25, 100, that's 64. 10 times 8 is 80 times 2, so 160 times cos A. And then like I was saying before, like instead of subtracting 100 and subtracting 64, I can just subtract 164 because I know that's what that adds up to. Oops, 164. Okay, so you can do that or do it in stages, whatever. I get negative 139 equals negative 160 times cos A. And I want to get cos A by itself, so I divide by whatever's in front, which is the negative 160. And again, I like having my unknown on the left side, so this is where I flip it over. And once again, I have two negatives, so I'm going to choose not to write them because two negatives make a positive. I want angle A, not cos A, so it's going to be angle A equals inverse cos of 139 over 160. Make sure you are in degrees. Okay, so second function, cos, bracket, 139 divided by 160. Close the bracket, hit equals 29.7 degrees. And that's rounding to one decimal place. All right, so I feel like you have the basics, people, of law of cosines. But we should like to do one problem. Let's do that. It won't flip ahead. There we go. All right, so here's the one problem. A parallelogram, hopefully you know that shape. If you don't, you'll see it in a second. Has adjacent sides that are 11 centimeters and 15 centimeters. The angle between these sides is 50 degrees. Determine the length of the shorter diagonal to the nearest tenth of a centimeter. Okay, so a couple things. Parallelogram, that's a shape. Okay, that looks like a rectangle. I always think it looks like a rectangle that's been kicked over. Like somebody walked over and gave a big boot to the corner and it's kind of bent it. So it's one of those. Adjacent means beside each other, right? So drawing my parallelogram. Before I get any further into that, just a reminder with problems, sometimes they'll have the triangle drawn for you. That's easy. That's going to be a lot like examples 1 through 4. Other times you have to draw them yourself. So those are the more challenging ones. So that's why I'm doing one of those. Now you're thinking we're talking triangles, but here's a parallelogram. Well, let's keep watching. Okay, so 15 and 11. Okay, so I'm going to put the 15 with the longer looking sides, and I'll put them on both. And then the 11 goes with the shorter looking sides. So I got those in there. Now the angle between these sides is 50. Okay, well there's 4 angles, right? There's each corner, right? So 1, 2, 3, 4. But 50, okay, so it's where the 15 and the 11 meet. Well, if I check out this first one, I'll put a 1 here. Well, that, if you kind of could look at it, it's more than 90. So if I draw like a 90 degree, that's more than 90. So that's not the one I should be putting it at. Down here, that one would be less than 90. So this second one here, that's less than 90. So that's where I could put it. So this is where my 50 could go. Okay, that would also be here. Okay, now it says determine the length of the short diagonal. So a diagonal is when you can connect two non-consecutive corners. So the shorter diagonal would be this one. And I've got a lot of pen on this one, but that's my shorter diagonal. If I connected the other two, that'd be my longer diagonal. Okay, so you likely are still thinking, okay, great, but we still have a parallelogram. So then what we want to do is just forget about this side and just focus on this side. And then now all of a sudden you have just a triangle, right? What other colors should I use? Well, we can just leave it there. And then if you want to add A, B, and C here, go for it. Okay, that's what I ended up doing. So go back to orange. Angle A is 50. I am looking for, I never really kind of focus on that, but I'm looking for the shorter diagonal. So that actually ends up being side A. So B I know is 15, and then C ends up being 11. Okay, then once you have the picture, it's just like the first 4 examples. So in a way I could stop, but I won't because then you won't be able to sleep tonight, because I know you love seeing me solve math. So let's keep going. I'm looking for a, so let's use the a version. So a squared plus the other 2 squared, so b squared plus c squared, always minus 2 times bc cos of a. And seeing I'm looking for the side length, I can have that kind of shorter calculation if your calculator allows. Okay, a squared equals 15 squared plus 11 squared minus 2 times 15 times 11 cos 50 degrees. All right, a squared. And then I could just enter all this in, which I did, and I ended up getting 133.9. So I always like estimating things. So like, I know that 144, which is more than this, square root of that is 12. Square root of 121, which is less than the 133, is 11. So I'm going to think it's about in the middle, right? 11.5. When I do the math, though, I end up getting 11.6. So it's good to kind of run that in your head real quick, and then you know if your calculator's give it, or you know if you've kind of typed it in right, like the calculator spit out a correct answer. You thought it should be 11.5, you got 11.6. If you would have got like 20.8, now you're like, oh, I must have typed something wrong. So that's why it's smart to think a little bit still when you're using your calculator. Okay, people, that's 20 minutes. So that's long enough. Thanks for watching. I hope it helped. If it didn't help, make sure you ask your teacher. And hey, if I'm your teacher, come talk to me. All right, have a great night, everybody.